Good afternoon friends, I welcome you all in this session. As you are aware, in previous session we discussed probability and different types of probabilities. We have seen probability under statistical independence and probability under statistical dependence. So far as probability under statistical dependence are concerned, we have got conditional probability, we have got joint probability and we have got marginal probability. So, we know that the conditional probability under statistical dependence is this. What is the probability of event B given that the event A has already happened? So, this is probability of B A and divided by probability of A, right. So, this is statistical, this is the conditional probability under statistical dependence. If you want to calculate the joint probability under statistical dependencies, you just multiply these two terms, you will get this, right. And what is marginal probability under statistical dependence? It is the sum of all joint probabilities having single event. Okay. And we have also worked out couple of examples on this. So, today we will see a couple of more examples on statistical dependence, that is conditional probability under statistical dependence. So, let us look at this example. According to a survey, the probability that a family owns 2 cars if its annual income is greater than 35,000 rupees is 75%. So, probability of having 2 cars is 75% having income greater than 35,000. Now, of the household surveyed, 60% had income over 35,000 and 52% had 2 cars. Now, what is the probability that the family has 2 cars given that income is over 35,000? So, this is a case of statistical conditional probability under statistical dependence, right. So, let us look at this. Let us say income is more than 35,000, C stands for 2 cars. So, I stands for income. So, probability that the family has 2 cars and income more than 35,000 is this. So, given that income is more than 35,000 and probability of car is C, right. So, this would be you just multiply these two values, right. So, this is how you should get answer to a question like this, right. Let us look at one more question. Friendly's departmental store has been the target of shoplifters during past month. Owing to increased security precautions, 250 shoplifters have been caught because of having security in place. Each shoplifter's gender was noted and it was also noted that whether the shoplifter was first time offender or a repeat offender. So, this is the summary. So, if you look at this total genders, total males 130, total females this is 80 is 120 and this is total 250, right. So, 130 120 and this is total 250, right. Now, assuming that an apprehended shoplifter is chosen at random, find the probability that the shoplifter is a male. So, is the probability that the shoplifter is a male? We have got total how many males? 130 out of all the shoplifters, right. So, it is 130 by 250, right. Now, second question is what is the probability that the shoplifter is first time offender given that he is a male or the shoplifter is male. what is the probability that the shoplifter is female given that shoplifter is a repeat offender, and probability that the shoplifter is female given that shoplifter is first time offender, and the shoplifter is both male and repeat offender. So, let us look at solution to this question. So, first part we have already calculated, right. The probability that shoplifter is first time offender and male. So, these are the notations. So, shoplifter male female, right, first time shoplifter and repeat offender, right. So, this how we have done this symbols, right. So, probability that this shoplifter is male and first time offender, right, this is what we have to calculate. So, this is probability that the shoplifter is first time and male given that he is male, right. So, this is the answer to this question. It is 60 by 250, 60 by total 250, right, it is total of these two, divided by 130 all the males, right, whether first time offender or repeat offender, all males. Shoplifter is female given a repeat offender, right. So, female you got 76, repeat offender and 146 of these are total repeat offenders. Okay. The next one is shoplifter is female given that the shoplifter is first time offender, female and first time offender. So, this is how you should calculate. First time offender you got 104 first time offenders and females are 44, right. Then shoplifter is both male female is 70 divided by 250, right. So, this is how you should answer a question like this. Now, let us look at Bayes theorem. It is quite an important theorem so far as decision making process is concerned, because what happens in real life situation, whenever you make a decision, you make that decision on the basis of certain information, and in real life what happens, initially you do not have all the necessary information. So, whatever information is available to you, you make decision as per that, and over a period of time you keep getting some more information, and then you would like to revise your probabilities of happening something or not happening something. So, that is the application of Bayes theorem. It is also known as posteriori probabilities, right. So, it is a perfect case of where we combine classical probability theory with subjective probabilities, right. So, with intuitive sense and with some classical probability and with some information we make certain decisions. We know that the conditional probability under statistical dependency is this, and this itself is called Bayes theorem, right. So, what is Bayes theorem? Bayes theorem is statistical, it is the conditional probability under statistical dependence, right. It is a powerful statistical tool for evaluating new information and revising our prior estimates of probabilities. So, how it works? So, initially you have got prior probabilities, you have calculated prior probabilities or probability of some event, and then you get some more information, then you apply Bayes theorem and then you get output, posterior probabilities. So, let us take an example. Let us say you have decided that the GDP in next financial year would be 8 percentage or 8 point, CGP and DGP would be 8 percentage or 8 point. Now, after some time of this estimate, you have got some more information. Let us say your rupee has strengthened, oil prices have come down, your inflation has come down, you have got good ties with your neighboring countries, you have got, let us say, the public sector companies starting doing well and so on. So, once you get all this information, you try to revise this estimate, and then you will say that the next year's GDP would be 9, not 8, is not it. So, the growth rate of GDP would be 9, not the 8. So, this is how you can apply Bayes theorem. So, we will take up an example. So, let us say you are manufacturing a part, and for manufacturing that part or that product, you have got two suppliers who are supplying you materials, right. So, there is a supplier supplying 65% of the quantity, and there is supplier 2 supplying 35% of the quantity. And we know from the past experience that supplier 1 supplies 98% good parts, it means 2% parts are not good, and in this case 5% parts are not good, right. So, let us say you have got material from these two suppliers and you have started working on those parts, and when you start manufacturing, then you found that a machine broke down due to some wrong part, the wrong material which you might have received from one of them, right. So, we have to find out what is the probability that the faulty part belongs to supplier 1 or supplier 2. So, we need to find out probability that the part came from supplier 1 or supplier 2, right. So, let us look at this tree diagram. So, you have got probability of quantity, it is 65% you are getting from supplier 1. So, P A 1, right, A 1 is nothing but supplier 1, from supplier 2 you are getting 35% quantity, right. Now, from supplier 1 good parts are 98%, this is 0.98. So, probability that part is good and from supplier 1 98%. So, just opposite to this would be what? Probability of bad part from supplier 1, which is 2%, right. Let us look at second supplier. So, from second supplier probability of good part is 95%, right, and bad part the probability is 0.05 or 5%. Let us look at probability of outcome. So, what is the probability that the part would be good and coming from supplier 1? So, you just multiply these two, 0.65 and 0.98, you will get 0.6370. What is the probability that the part is bad and coming from supplier 1? So, you just multiply this and this. So, 0.65 into 0.02 is 0.1030, right. Probability that the part is good coming from second supplier is 0.3325, and bad part is bad coming from supplier 2 is 0.1075, right. So, this is how you can calculate good part, bad part coming from supplier A and supplier B or supplier 1 and supplier 2, right. So, what is the probability that the part, this the question, right? What is the question? What is the probability that the part the part which has come is bad from supplier 1. So, for this you just multiply these two divided by this summation of this, right. So, from A1 you are getting how many parts? From A1 you are getting 65% of the parts, right. Just check this, from A1 65% and how many bed parts? 2%, just see this, 2% from supplier 1. From as far as supplier 2 is concerned, what is the probability that the part is bad and coming from supplier 2, right. So, either you call it S2 or A21 and the same thing. So, you are getting total 35% of the parts and 5% are bad, divided by total bad parts getting from supplier and total bad parts getting from supplier B, right. So, this is what we have done in first case. So, the total parts received multiplied by bad parts divided by the total parts and bad probability from supplier A and total parts from supplier B and probability of bad parts, right. So, this is how you can answer the question. So, what is the final answer? The probability that the part is bad and which has come from supplier A is 42.62% and 57.38%. The same answer can be found using a tabular approach. So, let us say from, so we have got prior probabilities 65% from supplier 1, 35% from supplier 2. So, you are getting total 100% parts, right. Bad parts conditional probability. So, this is the probability of bad part coming from supplier A is 2%, from supplier B 5%. So, you just multiply these two, the bad probabilities, right. So, summation of these two is 0.035. Now, divide this value by this number and divide this value by this number, right. So, you will get 42.62 and 57.38 percentage, right. Let us look at one more example. Given the probabilities of 3 events A, B and C occurring are 35%, 45% and 20%. So, this total is 100%, right. Assuming that A, B and C has occurred, the probability of another event X occurring are, so probability of event X occurring given that A has already occurred is 8%, this is this 65% and this is 3%. So, find probability of A given X has happened, B given X has happened, probability of C given X has happened, right. So, we have got probability of X given A happened, but what we have to find out? We have to find out what is the probability of A given X has happened, right. So, this is how you can solve it in tabular form. So, probability of event A, B and C, probability of X given A, B and C happened, right. So, probability of X and event is, you just multiply these values, right. So, these two is this, multiplication of these two is this and so on, right. Now, take the summation of all these 3 values. Now, this value divided by this total, this value divided by 0.6325 and so on, right. So, this is how you can get the answer. Now, after working out so many examples on conditional probability under statistical dependence, and after going through several other points related to probability and types of probability, let us work out couple of examples. So, this is our exercise. So, so these are couple of statements and you have to identify which one is true, which one is false, right. Let us look at first. In probability theory, the outcome from some experiment is known as an activity. In probability theory, the outcome from some experiment is known as an activity. This is false. It is not known as activity, but it is known as, either you call it sample space or outcome, right. The probability of two or more statistically independent events occurring together in succession is equal to the sum of their marginal probabilities. Is it? No, this is false. Okay. Using Bayes theorem, which we have just seen in this session, using Bayes theorem, we may develop revised probabilities based on new information. These revised probabilities are also known as posteriori probabilities. Yes, this is true, isn't it? So, prior probabilities and posterior probability. In classical probability, we can determine prior probabilities based on logical reasoning before any experiment take place. So, this is true, yes. So, there is no need of any experiment in case of classical probability. The set of all possible outcomes of an experiment is called sample space. Yes or no? Yes, it is true. Let us look at this point. Under statistical dependence, a marginal probability may be computed for some simple events by taking the product of probabilities of all joint events in which the simple event occurs. No, this is false. This is not the product, it is the sum. It is the sum of the probabilities of all joint events in which simple event occurs, right. So, this is false. When a list of events resulting from some experiment includes all possible outcomes, the list is said to be collectively exhaustive. Yes, it is. So, this is true, right. An unconditional probability is known as marginal probability. Yes, it is true, right. Unconditional probability is also known as marginal probability. So, this is true. A subjective probability may be nothing more than an educated guess. Yes, it is, isn't it. So, if you are an experienced person, you can estimate the probability of happening of an event, right. So, when the occurrence of some event has no effect on the probability of occurrence of some other event, the two events are said to be statistical independent. Yes, it is correct, they are statistically independent. When using the relative frequency approach of the probability figures become less accurate for large number of observers. Is it so? No, it is not. It becomes more accurate, right. So, this is false. 11th is false. Symbolically, a marginal probability is no, it is not denoted by PAB, it is just either PA or PB, right. So, this is false. If A and B are statistically dependent events, the probability of A and B occurring is this. 13th is false. No, this is not correct, right. Classical probability assumes that each of the possible outcomes of an experiment is equally likely. Yes, it is true. One reason that decision makers at high level often use subjective probability is that they are concerned with unique situations. Yes, it is true, isn't it, because for management most of the times they will face unique situations. So, they do not have data of those kind of situations, right. Past data are not available, right. So, they go for subjective approach. In assessing the probability of some event, the relative frequency of occurrence approach gives greater flexibility. 16th number is false. In assessing the probability of some event, the relative frequency of occurrence approach gives greater flexibility. No, this is false. Actually, what happens when you repeat experiment for larger amount of time, then accuracy increases. So, it does not give you greatest flexibility, right. Bayes theorem is formula used for finding conditional probability under statistical dependency. Yes, it is true. One disadvantage of subjective approach is subjective approach to probability, that it assumes a way unlikely event. So, this false. No, in case of subjective approach, a person can think of likely events and unlikely events, right. So, this is false. The relative, in fact, this is an advantage of subjective probability. It is not a disadvantage, right. So, had it been an advantage in this question, then it would have been a true statement, right. But it is unlikely and disadvantage, then it is false, right. So, the relative frequency approach to probability will provide correct statistical probability after no, this false. Okay. Let us look at next question. When using a subjective approach to probability, two people with same given information can produce different but equally correct answers. Yes, it is possible. It is possible. So, this is true. So, it depends on how much information both of them have, right. So, A and B are independent events if probability of A given that B has already happened is this. No, this is not correct, right. So, this is the correct answer. If one event is unaffected by the outcome of another event, the two events are said to be independent, is not it. So, B part is the correct one here. If probability of A or B is equal to probability of A, then what is this? Is there any statement correct? A and B are mutually exclusive? No. The Venn diagram areas of A and B overlap? No. P A plus B is joint probability? No, it is not like that. So, in fact, this is none of the above for this. The simple probability of an occurrence of an event is called marginal probability, right. Why are the events of coin toss mutually exclusive? Why the events of coin toss are mutually exclusive? Because the outcome of any toss is not affected by the outcome of those preceding it. Both a head and tail cannot turn up once any one toss. The probability of getting ahead and the probability of getting a trial are the same. All of this, no, this is the correct one, right, because both of them cannot happen at the same time. So, that is why they are mutually exclusive, right. If a Venn diagram were drawn for events A and B which are mutually exclusive, which of the following would always be true of A and B? Their parts of rectangles will overlap, their parts of rectangles will be equal in area, their parts of rectangles will not overlap, none of this. So, answer to this question is this, they will not overlap because they are mutually exclusive. So, it will be like this, A and B, right. What is the probability that, okay, since let us skip this one, but anyway let us try. What is the probability that a value chosen at random from a particular population is larger than the median of the population? So, you have got lots of data with you and you choose one data point. So, what is the probability that the data point is larger than median of the population? So, it is 50% chance, right. So, this is correct. Assume that a single fair die is rolled once. Which of the following is true? Assume that a single fair die is rolled once. Which of the following is true? The probability of rolling a number higher than 1 is 1 minus probability of 1 is rolled. The probability of rolling a 3 is 1 minus probability of 1, 2, 4, 5, 6 is rolled, the probability of rolling of 5 or 6 is higher than probability of rolling 3 or 4, all of this. So, the correct answer to this question is this E. So, A and B. So, A and B are correct and C is incorrect, right. Let us look at next one. If A and B are mutually exclusive events, then P A or P B is equal to this. How does the calculation of P or B change if A and B are not mutually exclusive? In fact, if you look at this, you will find that none of this is correct. In fact, it's not E is not the right answer. The answer is must be subtracted from, yeah, this is, you see, you need to subtract A and B. Why? Because this is a case like this, right. So, probability of A, probability of B, this A and B, right. So, P A or B is equal to P A plus P B minus P of A B. This common area is to be subtracted. So, A is correct in this case. Let us look at this. Leo C. Schwartz, a taxi driver in a city, has found that the weather affects his customers' tipping. If it is raining, his customers usually tip poorly. When it is not, he gets good tips, right. However, they usually tip well, right. So, which of the following is true? Tips and weather are statistically independent. The weather condition Leo cited are not mutually exclusive. Probability of good trip given that it has rained is larger than probability of bad trip given it has rained. None of this. So, for this, none of this is the answer, right. Let us look at 2 or 3 more questions, then we will wind up this session. Assume that a die is rolled twice in succession and that, okay, so let us skip this part 31, we will skip this also and we will skip 32 and 33 as well, right. Let us look at these questions. In fact, we can skip this as well, right. Okay, let us look at symbolically a marginal probability is what? It is P A. So, none of this is, all these are right. So, right answer is this. If we sum all the probabilities of the conditional event in which the event A occurs while under statistical dependence, the result is none of this, right. One of the possible outcomes of doing something is the activity that produces this outcome is experiment. So, this is 37, this is event, right, and this is experiment, is not it. The set of all possible outcomes of an activity is what? Sample space, right. This is sample space. A pictorial representation of probability concept using symbols to represent outcome is Venn diagram. Events that cannot happen together are called mutually exclusive events. The probability of one event occurring given that another event has occurred is called conditional probability, right. In terms of its assumptions, the least restrictive approach to study of probability is what? Least restrictive, it's subjective, it's subjective approach, right. Bayes theorem is often, let us first read this question. Theorem is often used in management decision because it provides way to update previous probability. So, it is a Bayes theorem. A list is if it is includes all the possible outcomes that can result from an experiment. So, what is this? A list is collectively exhaustive, right. And 3 different approaches are classical, relative frequency and subjective, right. So, with this I complete today's session. In next session we will start with probability distribution. Thank you very much.